Hey developers! If you don't know me, my name is Gilberto. I'm a software engineer and I love speak about what I'm learning right now or reviewing my knowledge. Nowadays, I'm studying data structure, as you know, and we we have talked about Big O, how we can use it to evaluate our codes. We also have we already have a brief about the arrays, about the hash maps, and now I wanna talk about a little about linked list. What is it? How we can do it? What is the Big O? Let's see it. So I will open my Notion, as you know, too. We are here, and here we have an image to illustrate what is this type of data structure, linked lists. So if you look at the image, you can see that we are not using indexes like 0, 1, 2, and etc. We have nodes to map where our data are. Okay? So you will have a node, and the nodes will uh, contain your data and also the next attribute to indicate what is the next node that will be the own data and your own next node and go on and etc. Also, we have a head that is the first node of our linked list because it's because they have its name because each node is linked with the next node. And well, we have taken took a look about hash map and arrays. And you maybe can be thinking, well, when I what are the scenario that I really need this type of data structure? So let's see. Um, Look to the methods of the linked list. Here, I will select to see. They have very fast methods to insert prepend, insert item on the beginning or at the final of the methods. So that is, if you need to do a lot of inserts in your data structure, maybe you can think of using linked list. Other thing that you may think is, whoa, but hash map do the same thing. Yes, but hash maps are not ordered. Here, you can order your list because one node link to other, while the hash map does not. Okay? So that is a difference between the linked list or hash map. You have the big O of 1 that is very fast, and we'll get an ordered list. But we'll not have a good you will not have a good performance when you try to get the value of one node because you need to iterate of the list always. When you want to insert one item at the middle of the node, so it's very fast only at the beginning and at the final of the linked list. And as well, when you delete, it is O of n. So to all these methods, the complexity, the time complexity of your algorithm will increase according with the size of the array. It's what it means. Now, I hope that you could understand what I'm saying. I will show you my code to make it more clear, to try make it more clear for you. Let me see. I will change my camera now. So now you are seeing my code. Don't worry about this quant of codes. I will bypass of each one right now. Let's go. So, like I said, append method. Look at this. To insert a method, I will zoom in here. So, let me make it better. Okay. I think, yes, in that way is good. So to add an item at the beginning of this data structure, I'm only creating a node that I will open this method that is like here. It's only a new object. I can open this later. So I'm only creating a node, very simple. And then I'm checking if I already have some nodes, some datas here. If not, my first date is my head and the tail of my data structure. And then by default, I'm setting the nodes as a head and increasing the length to 1. So I will never do a loop here because of this. It is a big one. But look at this, very interesting. I said earlier, insert have a big O of n because let's look at the codes. Here I'm doing some validations. I will not dive into it. If the index is 0, I do a prepend. Well, you just know why. You already know why. But see that what I'm looking, searching, what I'm looking for, I have one iteration. What is the iteration on my code? Here I check if it is inside the range, the index that I want to include the nodes. If not, I throw an error, index out of bound, and then I'm check if the index is equal the final of my nodes quantity. I'm doing append here because I already have this method. If this is the index that I want to include this node is 0, I do prepend. I already have this method. It is a big O of 1, 2. Oh, here, that's it. That's it. If you look to my code here, I have this method get by index. If I look into it, I'm doing a while or a for. I'm iterating of my lists. Let's look at my example here. You can see that I need to iterate to get, for example, the data on nodes that will be on the index 1, for example, considering that the first is 0 and the next is 1. So I'll need to iterate it. Because of it, let's get back to my codes. Because of it, my session have a big O of 1. Okay? That's the cause. So the same thing occurs when I remove some item. I use my get by because I need to replace the node, and that's it. That's it. So now, right now, I have talked a little bit about linked list. I hope you have enjoyed it. If you have some doubts, let me know in the comments. Bye. See you soon in my next explanation.